Hello everyone, welcome to my YouTube channel. My name is Turgut. Today I'm going to introduce you to my latest creation, a React application designed to identify plant diseases. Imagine having the power to classify any plant disease with just a photo. We will leverage the power of the neural network and convolutional neural networks. We will take advantage efficiency of transfer learning using MobileNet. We will train a model that accurately classify plant images. But that's not all. I seamlessly integrated this model into user-friendly React app, and to ensure smooth performance, we deployed this model in the Flask server using Python. This combination of technologies bridge the gap between advanced deep learning techniques and the practical everyday use. This is an end-to-end deep learning application. So let's dive in to explore how this app works and how I built it. Let me show you how this app works. It's just a demo. This is the React user interface. Here, and we can say just make a new prediction. When we click this button is go away, and it's just we have this drag and drop component. I have test data here. I just kept a few image our model didn't see when it's trained. And let's, for example, apple cider rust here, and this is a different apple disease, I think. And when we send it here, and then we can see the picture of the picture we uploaded, and we can see the predicted class apple cider apple rust. Okay, let me show you how I trained this model I train in Kaggle, and I run this train because it takes time. It will be a waste of time for all of us. Okay, first of all, we are just starting with importing and downloading dependencies. And just I'm going to run this. We just need TensorFlow to visualization, Matplotlib, NumPy, and also CV2. These are the important ones I'm going to mention. Okay, here I am checking the version of the libraries because when we deploy our model, because I am training this model in Kaggle environment, and the Kaggle environment, for example, it's used TensorFlow 2.13. And I don't, for example, when you build train a model, let's say using different versions, it might have a problem when you deploy it, and it might even affect the model performance. That's why I'm going to check this when I create my app when I deploy this model in the backend using Flask app. I'm going to download those dependencies according to these their versions to make it everything is and worked in the same environment. This is just a precaution, guys, because I had problems previously, not in this app. Before, when I deploy the model, it's mismatch model. Actually, framework versions cause a problem and just throw me an error. Okay, so we are just defining here image size. We are using MobileNet. MobileNet is just built for the deploying the deep learning model to mobile phones. So that's why image size is 224. We just decided the batch size is 32, channels is 3. Channels means RGB channels in the images. I opened here and image channels here. When you guys looked here, an image consists of the 3 channels, red, green, and blue. And this 3 channels is also there are, this image consists of these 3 channels. Okay, when we come here and we pick the batch size 32, and okay, we were just basically, this is this data sets in the Kaggle environment. You guys can just use the Kaggle environment. I just saying add data, and you can say these data sets are coming here. You can find whichever data sets you are work with, and these are showing some data sets I worked on. So okay, you are just clicking plus and just include that data set in your environment, and you can just read it like this here. Okay, this is my directory, and this is the diseases we have. And of course, there looks a little bit weird. There are dash between them. because underscore between them, and I cleaned it. That's why they looks really clean here, Apple Seller, Apple Rust. And I did it really programmatically. I will show that function and how I did it in the later in this notebook. Okay, I'm saying the plant diseases. That means in this data set, we have different plants: tomato, pepper, corn, grape, cherry, blueberry. And in these different plants, we have different diseases for each different plant. And there are a total 38 classes. And we have to classify those images according to these 38 classes. So, okay, I'm just saying that, just level warning, because TensorFlow just sometimes giving basic errors is not going to affect your model performance or how your notebooks works. Okay, just basically, this is another TensorFlow reading. This is an image generator. You guys can check the documentation in the TensorFlow. When you're working with these frameworks, you have to all the time look to documentation. Basically, just there are a few rescale. When you look at the images, image pixels consist of from 0 to 255. And we are rescaling it, just basically dividing them into 255 because it will be easier for our model to work on this scaled pixels. Okay, these are some different image augmentation methods, because we are working with a lot of classes. To classify this many classes, we need more images. We are just making different angles because and different angles, just arranging the range and just shifting the images to augment our data and to have more data for our trained data sets. That's why we are using. For validation, we're just rescaling it because it's just going to validate our image. Okay, then, and this is after you just create your generator, you can just say train data here, train data generator, flow from directory. You were just giving your directory location trained here. I showed about train directory, just basically in Kaggle. When you come here, in Kaggle, when you just come here, you can just see the train. For example, here, you can just copy the location and just give it to it. And okay, it's rated. We just set the target size, image size 224, and we set the batch size, class mode categorical, because our classes are categorical. Okay, so we are just checking the, is whatever did we write our data set, because just usually when you are working with the data, it's really important to you have your data is in right shape for your model, because at the end you will have an error. Okay, number of train generators, and this means 2,170, 197. That means we have batch. When you just multiply this with 32, here, let me show you real quick. Sorry. Yeah. Okay. Yes. So shift enter. Okay. As you can see here, this one is almost same as our data. So and for batch processing, probably adding more data into it. Okay. I don't know why the difference, but this means we have this amount batch. This is how many different images we have. Now, this is for the validation data. Okay, let's check the shape. And yes, that's what we expected. We have 32 means we have in our batch 32 images. They will go in batch to our model, and we have this 24, this is our image size, basically height and width, and 3, as I mentioned, they are the channels. Okay, for the labels, we have 32, of course, and 38 are how many class we have. Okay, let's visualize how our images looks like. And when you are working with this kind of things, you need an iterator just saying, because this is data generator and working with those generator, you are saying next. When you said next, they will give you, another batch of data. Okay, probably this images will be different because I run this notebook before I start this video. Let's see. Okay, we are just visual. Yes, as I said, this is when we said next, there will be different data sets from our, there will be a different batch from our data set. As you can see, these are the classes and which classes they belong to and their pictures. Okay. We have, these are healthy ones, I assume. Yes, these are healthy ones. These are diseases, different diseases. We are trying to, our purpose is just classify whether they're healthy or whether they have certain kind of disease. Okay, when we come here, when you are working with data, you need to check whether your data is balanced or unbalanced. If it's unbalanced, there are some techniques you need to work on or to find more data from the less data types or different things. But here, when we check it in here, it's just quick glimpse. When you look at it, it seems balanced, but always better way to see its visualization, which is the bar plots here. And as you can see, our data seems balanced. We are really good to go. We don't have to do anything about it. Okay, these are our categories, as I said. And by the way, I'm using GPUs in the, I showed before video, if you guys watch my earlier video, how can you use GPUs in the PyTorch? It's really intuitive. In TensorFlow, it's not complicated either. I'm just listing how many GPU I have. I activate it here, and you guys can use accelerator of the Kaggle. It's free, and you can use week lighting 24 hours, as far as I know. But as you can see, I have 2 GPU. But how can you use GPU in the TensorFlow? It's really basic. Just go to documentation. This is not this one. This one is if you have, this is using multiple GPUs. If you are using the single GPUs, you can just say the device and GPU name, and then you can just run. But you need to say width, after width, just saying the GPU, then comma, then as you can see, you were putting the calculations under that GPU, and it will start to use that GPU. Okay, here, I'm going to put a callback. Callbacks are really good to know in the TensorFlow. I was going to include the TensorFlow, TensorBoard callback too. There are real different things, and you can even save your train weights and everything. For example, I'm saying here an early stopping callback. Monitor, I basically say monitor my validation accuracy, and I just say patience. If in three epoch, if my validation accuracy is not improved, just stop the training. This is a really small amount because 3 is not a good amount, but we are using the transfer learning here. This model is already trained. We will just trying to adapt it, actually fine tuning it to our own data set. Okay, let's run this cell to this one too. I commented out because it's showing them giving you information about the GPUs. We don't need that, and just say the GPUs. This strategy is TF distributed mirrored strategy is just basically if you are using multiple GPUs, this one is just arrange your GPUs and run with your model in detail. You guys can check the documentation, of course. Okay, here. Basically, here we are just TF Keras application mobile net waits ImageNet. That means this mobile net architecture is trained on ImageNet data sets. It are famous data sets. It contains a lot of different pictures and different species, as far as I remember. And we were getting these weights, but we are saying include top false. And input shape. We are giving our input shape. Include top false. We don't want to end of the ImageNet architecture. we will just change that one and just making it work with our own thing. After we just, we are freezing here. After we get the base model, we are freezing its trainable. We are saying the base model is not trainable. We were just using those trained weights. We will just train after what we add. These parts are, after we set this base model is not trained, but after this model is freeze, now we are going to train. We are adding the average pooling. After that point, we are adding dropout. Dropout basically just randomly just drop to some weights in our neurons, just 20% of them. And then we are adding the dense layer. It's really basic. We were just adding 38 neuron just and making with the softmax function, just with the softmax, and just it will produce as a result. We were just running this with the, as I showed you above, is just 8 epoch, and it will train our model. It's a really good thing to taking advantage of the pre-trained models. Just transform learning is really good. I mentioned I use Hugging Face a lot. It's really convenient. Some model is trained, just get it off the top. Even we can even say this part is trainable too. It will even help us, because when people train these models in the huge amount of data, and these models start to learn the low level features, and they're really becoming good at it. And then you don't have to train those, because low level, what I mean when I say the low level features, just little edges, or basically just those lines, the columns, or just all little small edges our model already learned. It's common for almost every picture, so you don't have to train those parts, just train the upper levels. Of course, it depends on your scenario. You can change the upper top level and just add, for example, more dense layer here, maybe another convolutional layer. See, in the training model is just, train and learn, and just basically a basically scientific method, just observe and train again, and just make another train, and just observe, work out, just train another kind. Okay, I think this is enough. And as I said, we were just adding the category is 38, dense layer and activation softmax, and it will give us the result. Okay, so we are giving this model a name here. We are saying optimizer, Adam optimizer, and model.compile. We got the R optimizer and losses categorical cross entropy, as we have categorical features, more than one, and more than two, and metrics is categorical accuracy, of course, and we will use accuracy here. Okay, what we said after this point, we were just giving our training data and the validation data here, and just starting the train. And callbacks, you guys can add multiple callbacks here. Let's say TensorBoard, so on and so forth. There are many callbacks you guys can check, and they are really useful. I'm using them a lot. Okay, as you guys can see here, our model is start to accuracy is validation accuracy is 0.78, and then it increased the 0.93 with just 8 epoch, and we freeze all the layers before this part. We just trained this model in this part, and it's reached this validation accuracy, which is incredibly good result. Okay, after we trained our model, we can say there are different ways to save our model. Left Keras model save Keras H5 file, and you can load these models later on too. Okay, it's just warning about the probably this one, but it's still working fine. No worries, and don't take this serious right now, because I tried. And just after I set the history means here, and I just set the model fit the history. So just, make a visualization, see how my model is performed. Here, let's plot Okay, as you guys can see, our training and validation accuracy is just increasing altogether, which is a really good thing. And also our training and validation loss is decreasing together, which is really good. And we can train this model a little bit longer because I think there's a little bit uh, place to improve this performance. But this is the demo I'm showing you. You guys can just copy my notebook. It will be publicly available, and I'm going to share its links. You can just train more longer than mine. Okay, here I'm getting my categories here. Just it really looks ugly. These ones. I'm going to change this one. These underscores are looks weird, and this parentheses I didn't like. So okay. Okay, these are my test data sets. These are my tests. We will try a few of them. Okay, let's just see how our test data. Okay, this one is really seems healthy. Its auto name is Potato Healthy GPA, and you can see it looks really healthy. So when we just, we were just resizing the image here and taking this image and just resizing here for according to our model 224 height and width, and just making a prediction here and y hat. Okay, what is y hat? We have 38 classes. Let me show you here. And just add another block here. Okay, we have 48. This is our softmax output. We are going to argmax function here in and then it will give us the which one is the highest probability outcome from our softmax function. And let me show you the oh, okay, let me reload. Let me pause here. Okay, I'm sorry, somehow it's just we had a memory problem. We shouldn't keep open a lot of Chrome tab. I think I have a lot of open, but let me show you the predicted class index. Okay, 22, which is this is our classes. It will be 22. This is not our classes. These ones are our classes. Let's check which one is 22. 22. Potato healthy is 22, which is predicted accurately. Okay. Okay. Here. This is yes, it's predicted potato healthy, and this is correct. What are this? Okay, this is looks really bad, and I'm going to just basically just first of all just split these data sets according to these ones underscores. Then we will see empty slots here and this things. Let me show you actually how this works basically. Instead of I here, let me show you here. Yeah, we need this one. And instead of I, let me just take one of these and show you how this works. If you guys wonder how this part of codes works, it seems a little bit complicated. Okay, yes. When we just run this, it just makes target spot, but it's not get rid of this parentheses and the things inside the parentheses. And I'm using regex. This is a pattern for to match parentheses and what is inside the parentheses because I want to see more clear result. Let's run this. Not the clean list. Class label and plant list. I'm sorry, class labels. Okay, I forgot to change this one. Yes, now we have really clean results, so we can use for this results for our React app. Okay, I created a basic function here. So this function is taking our model and taking an image and taking the class labels and just returning us the, I'm trying another test image here. And as you can see, when we run this predict function, it will just return us the apple cedar apple rust, which is classified correctly these images. Okay, and then how can we just load back our model? And we were just saying that TF-Keras load model and giving our model path and just model name and just and we have new model, and let's try our new model with our function, or just, yes, exactly. It's works, and our model is new model, image is the Apple Cedar Rust, and just class tables are class tables. Okay, this is the how notebooks works. Let me guys know how this works. If you guys have any question about this notebook, just let me know. I will happy to explain. Then just just stay tuned, because after this video, I'm going to explain how React app works and how can we deploy this model. It's really convenient and easy. It's a basic process, of course, in this situation. And just stay tuned, guys. And after this video, there will be another one. Thank you so much.